So this question is basically about a non-uniform mass distribution or a variable mass distribution. So, well, both of them actually are not the same. There exists a minor difference between these two. But anyway, almost all the questions that we were doing so far were based on the concept of constant mass distribution. This time we have a non-uniform mass distribution, which is given to us as a function of x lambda is equal to lambda 0 into 1 minus x square by L square. Now, for our convenience, let us say lambda is f of x. Okay, so lambda as a function of x, we'll just convert that to f of x, and lambda 0 will be replaced by b. So what is f of x is equal to b into 1 minus x square by L square, and this f of x is actually the linear mass density. This is the linear mass density, which is actually mass per unit length. Given that f of x is the mass per unit length, we know that the x coordinate of center of mass, or x bar is equal to, so x bar is equal to integral 0 to L x into f of x dx by integral 0 to L f of x dx, which actually corresponds to the uniform distribution formula, wherein we have x bar is equal to, right, x bar is equal to sigma xi mi by sigma mi. Now see, the rest of this is purely integration, right? Excuse me for a second. Yeah, so it's purely integration. So we have numerator and denominator. We can evaluate them separately. So we have integral 0 to L x f of x dx is equal to, we have this complete derivation here, which gives us the value numerator being equal to bl square by 4. So we have numerator and denominator. Numerator is bl square by 4, and 0 to integral f of x dx, which is the denominator, can later be evaluated, which gives us the value as 2bl by 3. And when you divide these two, right, what you get is 3l divided by 8, and therefore x bar is equal to 3l divided by 8. And given the question that the value is 3l by alpha, so when you compare 3l by 8 by 3l by alpha, what we get is the value of alpha is equal to 8, then therefore the value of alpha is 8. So this is primarily what the question is all about. Now we will definitely come through, come back and analyze the overall process of, the complete process of integration here. But before that, the concept behind the question, which actually is the thing that we should be able to understand here. So it is given in the question that lambda is equal to lambda 0 into 1 minus x square by L0. So lambda is equal to lambda 0 into 1 minus x square by L square. So this lambda given to us is actually a function of x. So this is lambda of x. Why x? Because x 1 minus x square by L square. So you might be wondering, why not L and not x? That is where the understanding of the question becomes really important. Length is L, the complete length is L. So we have a rod assuming to be AB, whose length, the complete length is L. Okay, and it ranges from x equal to 0 at point A to x equal to L at point B. So what is lambda x? Lambda x is the linear mass density, which means the mass per unit length. So this lambda equal to lambda x is the linear mass density. What is x? X is the distance from A. So we're measuring this distance from A, or it can be defined as a location of a small element. So this is a small element with mass dm. I have to write that as well, with mass dm. So x represents the location of this element with mass dm. Now comes, what is lambda x dx? Lambda x dx. Okay, so lambda x is, the unit is m by L, right? Lambda x, the unit is m by L. So what will be lambda x into dx? It will be m by L into L. So L by L is 1. So what we get is m, which is the mass. So lambda x dx represents the mass of a small element. All right. Now this visualization is the key to understand the question in a much deeper way. There's this figure over here. Now we are not done. There's something more interesting that comes out of this value here, which is x bar is equal to 3l by alpha. Let us go through that as well. Well, we actually have derived that it is 3l by 8, right? So let's try to understand what does it mean physically. So if we consider this equation, f of x is equal to b into 1 minus x square by l square. This equation along the rod from A to B will have the minimum value at x equal to 0 and the maximum value at x equal to L. So f of x at x equal to 0 is f of x equal to 0, which is b into replacing x with 0, 1 minus 0 square by L square, which is equal to b, which is the maximum mass per length. Okay. Now, at x equal to L, we have f of x at x equal to L is f of x equal to L, which means replacing x by L. So we have L by L is L square by L square is 1. 1 minus 1 is 0, which becomes 0, which is the minimum mass per length. Mind you, we didn't say that the mass is 0. We said that the mass per unit length is 0, which means this rod AB is very dense near A, and as it goes towards B, the mass per unit length decreases and it almost approaches to be 0 at the maximum length L. Okay. Now, if we consider, why is this analysis important? Because if you consider mass, this rod over here, the maximum mass is closer to x equal to 0 and the minimum mass is closer to x equal to L. So this basically means that this rod here is denser, right? It is denser at A and it is lighter at B, corresponding positions at A, x equal to 0 and x equal to L. And this actually represents the concept of, those who have learned it in solid mechanics, this represents the concept of tapering beams, right? And the significance of larger bending moment in tapering beams, something that we'll discuss in solid mechanics. Now, how does it make, how is it relevant when it comes to discussion of center of mass? See, if we consider M1 to be the denser mass, and if we consider M2 to be the lighter mass, then the center of mass that we have calculated here is equal to the x coordinate of central mass is x bar is equal to 3l by 8, right? And again, we come to the conclusion that the center of mass is always closer to the mass which is denser or which is heavier. Why? Because here M1 was greater than M2 and therefore center of mass will be closer to M1. Now, okay, some of us may find it out here. How do you identify 3l by 8? So what is 3l by 8? 3l by 8 implies if you divide this length between M1 and M2 into 1, 2, 3, 4, 5, 6, 7 and 8 equal parts, then we have this position 1, 2, 3, this much position. This will be 3 by 8, right? This will be 3 by 8, the position of center of mass. I hope that makes sense. So yeah, so that is what I wanted to share about this question here. So a very beautiful question that actually correlates both your mathematical skills and your physics skills, the concepts in physics. Okay, now let us see the integration part.